Hello! Welcome to this RapidMiner Radoop tutorial. In this tutorial, we will briefly describe how to connect to Hadoop using the Radoop extension, and then we'll show you how to create a prediction using the Radoop operators. First thing to do before you get started with Hadoop is to install the Radoop extension from the RapidMiner marketplace. Please check out the video on extensions for detailed instructions. After the installation, you'll see an additional folder called Radoop in your extensions folder of the operators panel, and also the additional Hadoop data view. For this demonstration, we're using the Hortonworks sandbox. The 72 operators coming from the Radoop extension allow you, in essence, to seamlessly use a variety of functions for a number of technologies, such as Hive, Apache Spark, and Mahout, to prepare and to model your data. In order to access the data, we of course need to establish a connection to our Hadoop cluster, or in our case, to our small sandbox. The details on connecting to a cluster are beyond the scope of this tutorial, but we still want to briefly touch on the different elements of the setup dialog. To see the details of our existing connection, click on the Connections menu and select Manage Radoop Connections. You can see that we have a connection setup here called Hortonworks Sandbox. I'll select Configure to give you a quick walkthrough. You can see below the name of the connection and the option to fill in information about your specific installation. If you expand the Hadoop version dropdown, you can see the large number of platforms which we're supporting. In the next block, you have the master settings, where you can also add multiple masters for larger installations. I filled in the local IP address, as you can see, and left everything else at the default to match the sandbox settings. In the SQL settings, I've adjusted the default to be set to the latest Hive server version. Of course, you can also add your security settings, as for example, your Kerberos setup or others. For this demo, we've further adjusted the Spark version and the location of the Spark library and set one additional default Spark parameter. After you've adjusted your settings, we recommend you execute the quick test and the full test to ensure everything is working properly. Before we start creating a process, let's check out quickly the Hadoop data view. This view helps us to assess the data which is available for us in our cluster. We can retrieve the metadata by double-clicking on our connection. Once loaded, we have a nice overview of our tables. If we click, for example, on our Titanic_training table, we can see what attributes it contains. You could even retrieve a preview here if you need to take a quick look at a sample of your data. Now let's go back to our design view and start building a process with Radoop. We will drag and drop in the most important operator, which is called Radoop Nest. You'll find it all by itself on the top level of the Radoop extension folder, emphasizing its importance. The nest operator causes everything to happen on the cluster instead of on your local machine, which is what you want in order to use the power of your cluster. Let's connect the nest operator to the results port. By doing so, we're actually allowing information to be brought back to our local machine for display in the results view. However, it will always only be a sample to not clog your system. You can tick the Change Sample Size checkbox in the Parameters panel in order to see the sample size and adjust it to your needs. This is, by the way, one of the options to pull data from your cluster into your local environment and work with it there using the standard RapidMiner operators, or even in case you need to do a data dump. Keep in mind that the sample size will always work like a hard-coded filter. Now let's double-click the Nest operator to enter the sub-process level, where we'll configure a simple prediction on the Titanic incident. For that, we're going to use the sample data, which is available in your RapidMiner Studio Samples folder, just in case you want to follow along in a non-Radoop fashion. We'll start by using the retrieve operator from our Radoop extension. The name is in this case a bit misleading as we're not really retrieving the data, but it remains in Hadoop, as mentioned before. When we click on the table dropdown in the Parameters panel, we can see that we're now connecting our sandbox with the available tables, so the metadata has been gathered for us here as well. The table we want to use now is the Titanic training data. To show you what is in this data, we can simply execute the process. You're seeing an indication that it is running, and finally we get the data displayed because we had previously connected the Nest operator to our results port of RapidMiner Studio. In our case, it is really all the data, as our table is with just a bit more than 900 rows, or examples as we call them in RapidMiner, a very small data set. Looking at the data, you can see some of the known information about the passengers of that famous cruise. We do have, most importantly, a label, indicated here in green, which tells us who survived and who didn't. Also, we have some further information about the passengers like age, passenger class, gender, some information about family members on board, and the price they paid for the voyage, which we want to use to build a predictive model from. Now let's go back to our design view and into our nest operator. The second thing we're going to show you is a simple validation. We'll use a split validation operator here. Again, make sure to use the one from the Radoop extension folder. We will do a 70-30 split on our data. Now within the split operator, we have the two sides, one for training and one for testing the model. We will populate the two with a decision tree model, an apply model, and a performance operator, which we can drag and drop conveniently from our Wisdom of the Crowd section or from our Operators panel. For the decision tree, you can see the spark icon, and for the other two, you see the hive icon displayed on the operator. So for the nesting, we use standard Hadoop technology, and for the other features, we're using, as mentioned, other technologies such as Spark and Hive. All that just by pulling in the RapidMiner Radoop operators. We'll leave all settings as default except for the decision tree, where we'll select entropy as criterion, as that is better suited for attributes that occur in classes. If you'd like to learn some more on models, validation, and performance interpretation, please refer to the respective video in our Getting Started series, and also to the 5 Minutes with Ingo videos, which you can find on our YouTube channel. In this demo, we'll just continue to connect all the relevant ports in the training and in the testing section, so we can create and assess the quality of our model. In the last step, we will apply the model to some unlabeled data, which will conclude our prediction process. So let's move up to the relevant level to retrieve the unlabeled data. The unlabeled data has no information about the survival of the passengers which it contains, so this is what we want to model. To retrieve it, again we need to use the Retrieve from Hive operator, and this time we'll have it pull up the table called Titanic Unlabeled. We're going to apply our model to the new data. For that, we have to use again our Apply Model operator. Remember to use the one with the hive icon. So now we can connect the out port from our second retrieve operator to our apply model operator. We retrieve the model from the mod port of our validation operator, and we send the information to our results. We will output the now labeled data, the model, and the performance from our validation. This means we have 3 outputs which we need to account for also in our nest operator if we want to see everything displayed in the results view of RapidMiner Studio. So let's go one level up and provide 3 output connections. And as we execute this by hitting the Run Process button, you can see the progress on the execution indicated here by the icon. In the bottom, we get an information displayed what is currently executed. We're now in the validation. If we access the Hadoop cluster via our web browser, we can see that a job has been submitted and is status undefined. If we give it a bit of time, it will finish, so let's go back to RapidMiner Studio in the meantime and have a look at the results. The model we generated is a decision tree which is showing us that gender was the most important attribute to determine survival. So the women and children first etiquette was actually followed. The next important attributes were, not surprisingly, of a less noble background. It was passenger class and price of the ticket which determined the fate of the passengers. If we look at the output of our performance, we can see the overall accuracy, and finally, we can see the results of our prediction on the unlabeled data. It has been amended with a predicted label together with the confidence values. So this concludes our introductory tutorial on RapidMiner Radoop. The most important items to keep in mind is that everything needs to be nested in order to have it executed on the Hadoop cluster, instead of on your local machine or RapidMiner server. And the Radoop operators need to be used to execute the relevant steps. Of course, there are options to use the RapidMiner Radoop operators in conjunction with the usual RapidMiner operators, but this is beyond the scope of this brief video. Thank you very much for watching.